All right, I think we'll get started here. Again, my name is Brandon Van Cleve with Pine Cove Consulting. I'm Vice President here, based out of Bozeman, Montana. On our team, we have Dan Russell and Jace Holyoke. Dan is our CIO, CTO, kind of the brains of our operation from a solution standpoint, and what we bring to our customers. From the Sophos side, Seth Geftick is going to run with the deep learning presentation. We also have Paul Zendel and Samantha from Sophos as well. So thanks for everyone that joined. We're going to try to keep this to around 30 minutes and then open it up for questions. Feel free to ask questions at any point. You can put that in the chat box there down below on your panel. Ask them at any time. We'll try to get to them at the appropriate times. We do want to make sure we get through the full presentation, but we want this to be interactive. So please, chime in with any questions or comments that you have. This is I think this is our 5th webinar of the year. We started this in March. We've been pretty consistent on having these on a monthly basis. And I'll show you the list of all the webinars that we've had so far this year. But again, thanks for joining. And we'll get started here. So for those that don't know, if there anyone on the call that doesn't, who Pine Cove is, we're an IT consulting company based in Bozeman, Montana. We've been in the business for 24 years. We're about to go to our 25th year here in a couple months, which will be pretty cool. We're a solution provider that provides a wide array of different solutions, but we've really honed in on our cybersecurity practice and really have done a lot and really became a leader in our area in the cybersecurity arena. So I'm really excited about that. We serve on some National Security Council. We're on the Partner Advisory Council for Sophos. Dan does a lot with them from what they're bringing to market and what their different teams are working on. So that's pretty exciting that we get to be so heavily involved. Serve on some other local security teams and security councils that are trying to do some good work around the states. We won the National Cybersecurity Award for Sophos in 2016 for North America, which is really a cool honor for a small business here in the Montana, Wyoming area. And as you can see on the map, we're all over the place. We serve a lot of customers and put on a lot of miles to serve those customers. So no matter where you are in that map or even outside that map, we certainly can help you. And we service about 20,000 users a day, so we see a lot of things. We have a lot of different environments out there, and that's what we are so excited about. Our partnership with Sophos really makes our lives a lot easier with servicing our customers. That's a really busy slide, but I just wanted to throw out a couple of our examples of some of the customers that we have around our area that we're proud to service them and do different things across all these different states. And as we said, a leader in cybersecurity, there's a picture of us winning the 2016 award. We've been a Sophos partner since 2002. We have 33 Sophos certifications company-wide, and we're one of 12 partners in North America on the Sophos Advisory Council. So really heavily involved with Sophos, and really couldn't be happier with our partnership with them. And then as far as our webinar series, as you can see, there's our 4 other webinars that we've done this year. If you go to our YouTube channel, you can just search Pine Cove Consulting inside YouTube, and we have all of those presentations recorded. This one will be on that site probably a few days after this presentation. So go over there, check that out. Really some good information throughout that YouTube channel. And then just kind of my final slide here is as part of attending this webinar, we're going to put you in a contest for a giveaway that we're doing. So we're giving away the Sophos Phish Threat Simulation Campaign. So whoever wins that, and you get registered by attending our webinars, following us on social media, getting registered, all those things, and the more you do, we put your name in that many more times. So the more active you are with content that we're putting out there, the better chance you have to win. So if you did win that, we will set up for free a full Sophos Phish Threat campaign for you. So we will go through, we can add your users, we can help design it for you, we can look at the reports with you and see what kind of actions you want to take from it. So really a cool value, and highly recommend you get signed up for that. Okay. I had 6 slides, 6 minutes in. I'm going to kick it over to Seth here and let him get into the good stuff. So go ahead, Seth.
Great, thanks so much. I'm going to go ahead and share my screen with you guys. So today we're going to talk about deep learning. The phrase deep learning can be a bit confusing. Deep learning is an advanced form of machine learning. So sometimes you'll hear people talk about machine learning. Sometimes you'll hear people talk about artificial intelligence. And sometimes you'll hear people talk about data science. They're all kind of related terms. Right? Make sure I have the right screen showing here. Sorry. Looks good. So deep learning is an advanced form of machine learning, and machine learning is a type of artificial intelligence, and the discipline there is data science. So when we talk about the data scientists, they're the ones who build these models. And I'm sure when I say machine learning, I can see you guys on the other end. If you've been to any security conference, RSA security conference, Black Hat, people say machine learning, machine learning, machine learning. It seems like the magical answer to every security question these days. So I'm sure you guys are rolling your eyes on the other end of the phone to a bit. But machine learning, while it's become a marketing buzzword recently, it's not a new concept. It's been around for decades. In fact, Alan Turing, the famous computer scientist, was working on this as far back as World War II. Talk about the Turing machine. If you've seen the movie, about him, you would know that this is a thing that has made major strides in stopping wars, but now we're applying it to cybersecurity, and people have been doing this for several years now. And one of the reasons we're doing this is because machine learning has some inherent advantages to it. So for example, while we struggle with big data, we always hear about big data, the solution to every problem in the world, well, big data itself is a problem, because you have to be able to handle all that volume of data and do something with it. So machine learning obviously works at machine speed to thwart attacks. So in a day and age where our attackers, our nemesis, becomes more and more advanced, we need better tools in our arsenal to respond. And we need things to help make up for the fact that we don't have unlimited resources, both technical resources and human resources. So being able to work at machine speed really gives us a better chance at stopping attacks. Some of the really cool things about machine learning, specifically when it comes to endpoint security, is that you don't need to rely on signatures alone anymore, because machine learning doesn't use signatures at all. Right? It's completely algorithmically based. So that gives us the ability to stop not just known malware, but unknown malware we haven't seen before. Of course, there are many cases beyond malware where machine learning applies to cybersecurity, and certainly at Sophos we're doing a lot around things there, but a lot of what we're going to talk about today is specific to malware. Right? One of the great things about machine learning is we can use it to stop malware pre-execution. That means the file that we're looking at doesn't even need to run before we can analyze it and determine if it's good or bad. So if you think about the chain of defense, or how we want to stop an attack, essentially you're able to now stop a piece of malware before it ever has to run. So you don't even need to worry about its behavior, because we'll stop it before it even executes. And overall, what we really care about is machine learning gives us the hope of higher detection rates with lower false positives. So before I dig in too far, let's go through basics of how machine learning works. So we'll create a little simple example here. So where the universe is simple, we'll have, instead of looking at malware, let's think about it in terms of maliciousness of an HTML file. So we're going to look at 2 specific features to try to build a model to determine if an HTML file is good or bad. One is the file length, and one will be the number of links for the file. So obviously this is a very optimistic approach. It'd be great if predictions were this easy. But for this example, we're going to make it nice and simple. So we're going to plot all of our X's and O's. X represent malicious HTML files. O's represent benign files. So the way supervised machine learning works is we feed a lot of data into a model. The model takes that input data, trains on it, and adjusts itself to correctly predict an outcome. So in this case, we were able to pretty easily draw a linear line and see, yep, everything on one side of that line is malicious, and everything on the other side of that is benign. In a more complex model, it wouldn't exactly be a straight line. It'd be more of a squiggly line. Right? Machine learning is able to do that. But so what we do is machine learning model will train on these features, categorize a series of test files, establish a decision boundary between the two groups, which is that line. Everything on one side's good, everything on one side's bad. We then test the model and see, hey, looks like we're doing pretty well. The X's fall with the X's, the O's fall on the O part of the line, and we're feeling pretty good about our basic model here. However, it's normally not that simple, right? If we kept running this model with more and more files, we'd probably see a lot of mistakes or false positives. We'd see some files that we predicted were malicious were actually benign, and vice versa, so false negatives in that case. So we want to make our model better. So how do we do that? We're going to add more inputs into it. We're going to make the model more complex. So instead of 2 features we're looking at, we're actually going to look at 3 features. Now when we're doing a model, we have to do it on a 3-dimensional plane, right? So in addition to number of links and file length, we're going to add word count to our model. Right? At this point, I don't know about you, but my brain starts to hurt to think about 3-dimensional models and putting things in a graph there and hoping that we end up on the right side of that decision boundary. But this is still really, really simple. Like human beings can do this with pen and paper if they had to. But what happens when you start adding more features, right, and more inputs? Let's go up to 10 now. Pretty soon you're going to realize that the model is going to become too complex for human beings to compute, and we need machines and machine learning to help us keep going. So something like this, a 10-input model, would be almost impossible for us to visualize. So if we actually tried to visualize this, if this was a real 10-dimensional cube, every angle in here would be 90 degrees, all the lines would be equal length. I mean, for us, it's a bit of a head splitter. But for machine learning algorithms, this is the kind of high-dimensional space that they exist in. Except in machine learning or data science as applies to security, most problems we care about don't have 2 or 3 or even 10 dimensions. They have thousands or millions of dimensions. And this is where deep learning neural networks, or deep learning, really come to the rescue. So deep learning, which is named after the complex interconnected neural pathways of the human brain, essentially trying to mimic the way the human brain thinks to a degree, helps out a lot with this, because what we do here is we're able to take information, run it through a multi-stage model, and each layer of that model, each analysis layer, makes the model considerably more powerful. So we put inputs in, and then each of these hidden layers will essentially kind of be like weights, where they're manipulating the data and looking at different connections between different inputs, and doing that over and over again until we get to an output. Right? So that's a very simple way to describe a very complicated process, and something that obviously is an entire discipline of itself. One thing to note, while we're talking about deep learning here, again, deep learning is just one type of machine learning model. There's lots of different types of machine learning model, but this is one that we find to be really effective and one we rely on a lot here at Sophos. What's interesting about deep learning is it's all around us every day. So if you've never heard of it before this presentation, you've certainly interacted with it. Deep learning is the type of machine learning that's the basis behind facial recognition. So if you use your iPhone and you look at someone's picture and you can see other pictures in your queue, in your photo library of that person based on image recognition, that's deep learning in action. It's also an action when you talk to your Alexa, when you talk to your Amazon Echo and have a conversation with it. That's deep learning. And deep learning is at the heart of self-driving cars. So it's all around us every day and changing the world. Now it's having an impact on cybersecurity as well. So let's dig into that a bit. So we know we could do fun things with image recognition and deep learning. So in the past on the internet, if you wanted to look up a photo of a cat, someone would have had to inputted that photo and labeled it a cat for us to search it. Now with image recognition, we can find cats. Image recognition is so sophisticated that we can do really cool differentiators. Like if you want to look at the difference between a mop or a dog, machine learning can figure that out for you. Parakeets or parrots and guacamole, no problem. Right, this is the type of, there's a million of these. These are really fun to play around with. So how exactly is machine learning able to do image recognition? So let's consider a simple example. We're trying to build a model here that would help us determine if we could find pictures of apples, tomatoes, and cats. So we want to find some cats on the internet, which is the internet's #1 thing to do. So to do that, we're going to go ahead and build a machine learning model. So first we start with the training process. So the same way the human brain works, the same way deep learning works here. So if you think about a little kid who's never seen a cat or a dog before, over time, that child will eventually be able to learn the difference between the two. And the way you do that is by taking millions of different examples, or in a kid's case, probably dozens. Say these look like cats, these look like dogs, and the human brain is able to find the features between those two. And a child eventually says, okay, now I know the difference between a cat and a dog. Deep learning pretty much does the same thing here. So we take a model, we take tons of training images, we feed it into our model, and we train it. For each of those images, we would have to correctly label it. So we'd say this is a picture of a cat, this is a picture of a dog, this is a tomato, this is an apple. And the model, while we train it, will learn those features. And should output a learned model that we can predict here. So the challenge here is first getting really good data to input into the model, right? Garbage in, garbage out, quality in, quality out, which is a nice advantage we have here at Sophos because our data science team falls under the Sophos Labs team. So we have a ton of really rich data to work with. The second thing is properly training the labels, properly labeling the training data. And then, of course, having the data science to both understand machine learning as well as understand security to build that model. So think about the features that go into it. So the first thing you need to do in a machine learning model is have the right inputs to get the right outputs. And the inputs is not just the training data, but millions of different features that go into that. So if you're talking about a piece of malware, you're talking about different attributes of the malware. If you're talking about a picture of cat, we're talking about different attributes of the cat. You know, the fur, the oval eyes, the ears, the triangle nose, right? So when machine learning works, it does image recognition. It's taking all of these different factors, and those are the different features that get inputted into the model to output yes, cat, or no cat. And it probably goes beyond what we think of as human beings, and it might even do the distance between eyes or the curve of the nose that would indicate whether it's a cat or not. So when we test the model, we already have a model that we've built, we test it. We take that picture of the cat, and probably many more pictures similar to that. We enter into our model, we see the prediction it comes out with, and we test to see if the model is accurate or not. Do we have high detection rate with low false positives? Right? And this actually works, right? So this is a real picture of a cat. We put it on a website. There's Clarify AI. You see .com. Google has this. Real image recognition sites out there. You put this picture of a cat in, and out will predict different features of it with certain amounts of probability. So this Clarify site says 100% sure that this is a cat. They're 99.6% sure it's a pet, 99.3% sure that it's an animal, 98.6% sure it has fur, but not all models are 100% correct. You could see they said it was a 99.8% chance it was cute, and I'd argue that's a 100% chance that's a cute cat. Right? So this is deep learning at its most basic, taking features, looking at it together, and coming up with a prediction for an output. The difference is we're not really interested in determining the difference between cats and dog pictures. We're looking at determining malware detection. So separating good programs or benignware from bad programs or malware. So why specifically do we use deep learning? I mentioned earlier there's lots of different types of machine learning, but we specialize and we really rely on deep learning itself. So why are we so fond of it? So unlike other traditional machine learning, deep learning is able to process data through those multiple analysis layers, and each of those layers makes the model considerably more powerful. So this allows us to uncover the best combination and manipulation of inputs that would otherwise be impossible for human beings to determine. So with deep learning, that combination and manipulation of inputs, essentially the attributes that we want to look at, are automatically learned by the model. Other types of machine learning has to be extracted manually. So a human being would have to determine what the inputs are into the model that are most important for the model to spit out the correct outcome, right? Which automatically inserts human bias into the science. Another advantage of the Sophos deep learning model is that we elegantly scale to hundreds of millions of training examples. So in other words, we can memorize, so to speak, the entire observable threat landscape at any given time as part of our training, which should make the model improve and be ahead of the curve, so to speak, because we are able to scale so much greater in the data that we train and look at because of this neural network deep learning setup. Other models really struggle as the amount of data that you're looking at grows, which makes it harder to solve complex problems such as detecting malware. And the third advantage of deep learning versus other types of machine learning is the small size of the model. So while traditional machine learning approaches might have huge model sizes, which could take gigs on the disk and take up a lot of precious processing power, our deep learning approach results in much more compressed models that only sacrifice a really small amount of compute power. So essentially, with Sophos deep learning technology, when we have a new file, we're able to extract millions of features, run it through the model in milliseconds, and categorize it with astonishing accuracy and speed. So essentially, we separate the good from the bad in just milliseconds before the file would ever even execute. All of that helps us stay ahead of the attacker and not just keep us safe today, but keep us safe tomorrow. So some of the things that make us experts at deep learning and machine learning, I mentioned before that people roll their eyes when they talk about machine learning. And certainly we have competitors out there who might be saying Sophos is new to this, they're just throwing out a marketing buzzword. But that's actually not true. We've been doing this for quite a long time and have real results. Right? So we productized, this technology has been productized for over a year, so it's been protecting customers in real environments for well over a year at this point, and have a product that's really better than anyone else in the industry. So we have the #1 malware detection rate, so the best balance of false positives and detection rate. And this technology that's now part of the data science team at Sophos Labs was originally came out of a DARPA-funded program. So this is originally a DARPA research project of years of development that eventually became productized as a cybersecurity product. And again, some of the advantages here is not just that we can detect malware, but we can detect unknown malware. So malware that's never been seen before, so we don't need to rely on signatures to detect it. And we do that all in milliseconds, and we do that all before the malware even executes in the first place. So testing machine learning models is really difficult. There's a lot of different approaches and different claims out there. Certainly vendors will always claim that they have the best. We've actually been proven, so the deep learning models on VirusTotal today, it's proven on VirusTotal, it's been validated by third parties, and even here we have an amazing quote from Mike Morgenstern, the CTO of AV-Test, talking about how this was one of the best performance scores they've ever seen in any of their tests. An exciting part is this technology is going to be integrated with the Intercept X product. So for those of you out there that use Intercept X, you already know it's a very powerful product on its own today. So the anti-exploit capabilities, the anti-ransomware with CryptoGuard capabilities, or Intercept X, have proven to be really effective. Once the deep learning capabilities are layered on top of it, we have the best defense in depth strategy of any endpoint tool on the marketplace, which at the end of the day should help us detect more with less false positives, giving us a really unique advantage and the best endpoint product on the market. So with that, I think we are just a few minutes left on the call. Happy to take any questions that you guys have. So I know this concept can sometimes be a bit overwhelming. Hopefully this was a good, simple overview of what we're doing here at Sophos and why we're so excited about the deep learning technology, and also how deep learning is different than just the blanket term machine learning. So it's certainly a more advanced form, one that we have a lot of expertise with, and one that's going to make a real difference for our customers.
So, Seth, can you talk about a time frame of when we're going to see that? Has that been defined?
Yeah, I mean, certainly with all the usual caveats that roadmaps can change and plans can change, but the plan is to have this integrated with Intercept X by the end of the year, or at least, yeah.
Okay, and people can continue to put questions down in the questions tab. I think what we plan to do as a follow-up to this too is when this is actually released, we'll do basically a follow-up where we actually can get in and show kind of the meat of what we're doing live in environments like we've done in some of our other presentations. So our goal today was just to at least introduce the concept and get people thinking about it and knowing what is coming forward for our customers or potential customers. So I guess if there's no other questions, I don't know if anyone else on the panel has anything. Otherwise, we can wrap it up. We will shoot this recording out, and we'll definitely post it as well. So if you need to review this or share it with anyone, feel free to do that.